Hello and welcome back to ISOMath. Today we're going to talk about polar coordinates. Alright, before we get into polar coordinates, let's talk about what we know in terms of rectangular coordinates. That's obviously our coordinate system here when I have an arbitrary x and y that intersect at the origin here. And if I want to locate the point, say 2, 1, I need to go over 1, 2, and then up 1, and then that can plot that point right there, and that's my point 2, 1. Again, this was, came about with Descartes, French mathematician back in the day. He was the one that gave us the coordinate grid system. And that's why it's often referred to as a Cartesian plane, because of the honor of Descartes, who helped us discover it. So, however, sometimes I can have another system to measure coordinates, and one of the other possibilities is one called polar coordinates, and we're going to show you how that works. If I take and superimpose a circle onto this coordinate plane, yes, I've now created the essentially a unit circle because it has a radius 1 and going all the way through here. But if I wanted to locate this point right here, I can also obviously use my rectangular coordinates to get there, but there's another method using polar coordinates, and that simply is by coming through and taking a line and measuring the angle that this creates between the positive x-axis, this theta angle, and actually the length of this line segment here. Well, if I use this, we obviously know that this line segment this is radius 1, so this line segment has 1, and this theta right here, the one I created, is actually a 45-degree angle, or a pi over 4. So I can locate that point in a polar coordinates. It simply comes down to the radius, which has in this case 1, and the theta, the angle it measures, has an angle of pi over 4. And I've always started at the origin, and my radius tells me I have a line segment, a length of 1 that's created with an angle of pi over 4. So my coordinates in the rectangular plane can be simply given by the r comma theta, and in this case it would be 1 comma pi over 4, and that'll give me this location 1 comma pi over 4 in the polar coordinate plane. Obviously we know it to be in the rectangular coordinate plane. That is the same as the square root of 2 over 2 comma square root of 2 over 2, because I'm creating that 45-degree angle, and on the unit circle we know what the sine and cosine is of that value. But that's the idea behind that's the idea behind polar coordinates. And Professor Axler in his book defines polar coordinates as r being your radius and theta of a point in the coordinate plane. They're characterized as follows. The polar coordinates r is the distance from the origin to the point in question, and the polar coordinate theta is the angle between the positive horizontal axis and the line segment from the origin to that point. So this ends up being your theta right here, and this line segment here ends up being your r. And that's how we go about finding polar coordinates. So, again, I can identify any point using theta and r. It's just a new coordinate plane system. Here's an example in terms of the endpoint of this line segment has a polar coordinates of r equals 3 and theta equals pi over 4. So interesting enough, let's think about this for a second. This could be, instead of taking the unit circle, I could also take obviously a circle with a radius of 3, and that will put me on there right there. And if I needed to convert this, this point right here, that point right there, from polar coordinates into rectangular coordinates, let's try to do a little brainstorming and try to figure out how I could do that. If we put on our critical thinking hats, and what we need to find out is if this is my this is my x-axis, and this is obviously my y-axis, I need to find a way to put this coordinate into my x and y-axis. Well, remember from the unit circle that if I drop this down and to make a perpendicular line, I can form what is essentially this x and this y. I can come out and go through this. This value of x, remember from the unit circle, and again I know we're on radius 3 though, but this x coordinate is nothing more than cosine of theta on the unit circle. However, on a circle that's bigger than 1, it is nothing more than r cosine of theta. r cosine meaning the radius. For instance, remember from back when, if I had a circle with a radius 3, I can find out the cosine by simply multiplying the 3 times the cosine of that angle. So this ends up being r cosine of theta, and my y is also has the value of r sine of theta. We know it should be the old sine of theta, but if I'm outside, not on the unit circle anymore, just a regular circle, it's going to be the radius times the sine of that circle. So, converting from polar coordinates to rectangular coordinates, we have this x value now is equivalent to r cosine of theta, and this y value is equivalent to r sine of theta in the xy plane. So that's how I can convert from polar coordinates to rectangular coordinates. If I want to go the other way, converting from rectangular to polar coordinates, I use the same idea here. If I know this point to be an xy coordinate, I need to be able to find the r, and I need to find out the angle theta that it makes. The angle theta that it makes between that to convert back the other way. Well, we know that r, this r distance here, is nothing more than the distance between the origin, the 0, 0, and this point is going to be nothing more than the x2 minus x1 quantity squared plus y2 minus y1 quantity squared. But since I'm dealing with the other points, the origin, those values are 0. So this ends up being nothing more than r is equivalent to the square root of x squared plus y squared. And that's going to give me that hypotenuse layer. You can also look at it as a right triangle. And this is nothing more than, since I have the right triangle, x squared plus y squared is equivalent to r squared. And then when I take the square root of it, I get that value either way. So either looking at it as a distance formula, or you can look at it as a right triangle with the two legs squared is equivalent, added together is equivalent to the hypotenuse squared. You're still going to get it. So, and then I need to find out what angle that creates with theta. So here's an example. It says find the polar coordinates for this point with a rectangular coordinate of 1, 1. So let's figure out how we could do that. So if I go through here, I know that this value right here is 1, 1. So coming out for my r squared, I know that's going to be nothing more than 1 squared plus 1 squared, which is going to give me, obviously, the r value here is going to be the square root of 2. So that's going to give me the square root of 2. That's not a problem. Now to find theta, what I need to do is I need to use my tangent formula. Because remember, this theta angle, I can use my tangent, which is nothing more than opposite over adjacent, or in this case, the y value over the x value. And we know my y value has a value of 1, and my x value has a value of 1. So my tangent of theta is going to be equaling 1 over 1. And then to find out what that theta is, then I need to find the arctan, or the inverse tan. So theta is equivalent to the inverse tan of y over x. And obviously in this case it's 1 over 1. And the inverse tan of 1 is nothing more than pi over 4. However, remember, I can have multiple answers for this guy with the pi over 4. Because I can have essentially not only pi over 4, but I can also have an additional 2 pi will give me the same spot, right? So I can have pi over 4 plus 2 pi, or plus a 4 pi, or plus any multiples of 2 pi, get me all the way through there. But essentially what I'm going to be looking for is I'm going to be looking for the smallest angle, theta, that makes that true. So here it is, and Professor Axler talks about converting from rectangular to polar coordinates. You're going to take essentially this to find out the r value. That's how to find the r. Given the this is when you're given the x and the y, you want to convert to polar coordinates. You take the square root of x squared plus y squared, and to find out the angle, you take the tangent angle of theta of y over x, and obviously you're going to have to use the arctan or the inverse tan to find out that value. So going through that, that's going to help me in terms of again choosing the correct polar coordinates. This is an outline to help you stay on track. So when basically if the x value is less than 0, these are some of the stipulations you want to be comfortable with. Well, we'll go ahead and work out an example. So it says, this one says find the polar coordinates for the point with rectangular coordinates of 1, negative 1. So let's take a look at how we do this. We know that coming down, this is going to be the angle. This is going to be down here. This is my value of 1, negative 1. We should be comfortable, obviously, knowing that that's going to be creating a negative pi over 4 value, or the angle itself has a value of pi over 4. And this obviously, since I'm 1, 1, I'm on the, I can come out here and doing the x squared plus y squared, that's going to be the square root of 2. So that's my angle through there, but I need to make sure that The point with rectangular coordinates has my r value is going to be square root of 2, and my theta is negative pi over 4. Yes, there are other possibilities going through there, but we want to get there quick, and that's how we can get there quick. And that's, again, using my summary chart, I can find out the best angle of theta to give me that correct value. So here, if I want to find the full polar coordinates with the rectangular coordinates of 1, negative 1, that again is going to put me over here in the second quadrant. And that tells me, again, I know I can get comfortable getting my r, my radius is going to be square root of 2, but my angle tangent now is theta is going to be essentially 3 pi over 4. So again, here I have now a unit, or not a unit circle, but here I have a circle with radius 3. X squared plus y squared equals 9, and I can go through and find this. I can identify this circle. This circle can also be in polar coordinates, can be identified simply as just R3. So I have a circle in rectangular or polar coordinates can be classified as just simply R3, and you're done. That is the equation of this circle. Well, obviously in rectangular coordinates, I got to do x squared plus y squared equals 9. So there are times when the polar coordinates are more convenient. So I hope this has helped, and remember, check back to ISOMath for all your math needs, and we'll see you soon.